8 commits on your feature branch. You run one rebase, 0 of them survive. The code is identical, but every commit object is gone, replaced by a brand new one with a different hash. The originals are still sitting in your repository right now, orphaned, waiting for garbage collection to delete them. That is the real difference between merge and rebase, and almost nobody explains it that way. So here is what these two commands actually do to your history, and also exactly when each one is going to hurt you. Start with merge, because merge is the honest one. When you merge feature into main, Git first walks back to find the common ancestor of the two branches. Now it has the point where they diverged, plus both branch tips. It takes the changes from each side and combines them. Then it writes exactly one new commit. And that commit is unusual because it has two parents instead of one. Every other commit in your repository points back at a single parent. A merge commit points at two. That is the whole trick. The merge commit is a join node, and the join is the thing that's being recorded, and nothing that existed before it gets touched. Your feature commits keep their original hashes, their original parents, their original timestamps. Your history now contains a fork and a join, and that shape is permanent. Here is what that actually looks like in git log with graph flag turned on. The branch peels off after update dependencies, runs for 3 commits, and merges back in at E1, F2, A3B commit. That diamond is a record of something that genuinely happened. Two lines of work existed at that same time, and this is where they came back together. There is one exception worth knowing about though, and it catches people out constantly. If main has not moved at all since you branched, there is nothing to join. Git simply slides the main pointer forward onto your last commit. That is a fast forward and it produces no merge commit at all. If you want the join to always exist, you pass dash dash no dash ff. Rebase does not merge anything. That word is not even in the algorithm. What Rebase does is replay. First, Git works out which commits are unique to your branch, the ones that exist on feature and do not exist on main. For each one, it computes a patch, which is just a diff that commit introduced, stripped of any parent. Then it takes your branch pointer and moves it to the tip of the main. And then it applies those patches one at a time in order on top of the new base. Every single application creates a brand new commit, new parent, new tree, new committer timestamp, and therefore a completely different SHA. And here is a detail that almost everyone gets wrong. The author date is preserved, but the committed date is rewritten to right now. So a rebased history can look perfectly chronological while the other dates quietly say otherwise. Both are stored, only one of them is shown to you. The result is a straight line. The same work, commit for commit, line for line. But the branch is gone, the diamond is gone, and every hash on your feature work has changed. Put the two histories next to each other and the trade is pretty obvious. Merge tells you what exactly happened, Rebase tells you a cleaner story about what happened. Neither of them is lying to you, but only one of them is evidence. Now, the part that actually decides which one you're going to regret. In a merge, you resolve conflicts exactly once. Git compares both branches steps against the common ancestor once. You fix the overlap in a single setting and you commit. One resolution, one merge commit, finished. In a rebase, you resolve conflict per commit. Your patches are being applied one at a time. So the moment a commit touches lines that main has changed, the rebase stops. You fix it, you run git rebase, continue, and it moves on to the next commit, where the very same conflict can hit you again and again on the same after commit. 8 commits touching a file that main rewrote can mean 8 separate resolutions of what is essentially the same problem. This is the single biggest reason engineers try rebase once, hate it, and go straight back to merge forever. Two things fix it, and both of them are one-time setup. The first is rerere, reuse recorded resolution. Turn it on once and Git memorizes how you resolved a conflict. The next time it sees the exact same conflict, it reapplies your fix automatically, which collapses those 8 resolutions straight back down to 1. The second is to squash or reorder with an interactive rebase first. So you're not dragging 8 noisy commits through the same collision. And if it goes badly, git rebase abort puts you back exactly where you started. There is genuinely no reason to panic in the middle of a rebase. Here is where rebase stops being a style preference and starts being a way to ruin somebody else's afternoon. Remember what rebase does. It replaces your commits with new ones. If those commits only ever existed on your machine, nobody notices and nothing breaks. But if you already push that to the branch, the remote is still holding the old commits. Your local branch and the remote branch now have 0 commits in common. So a normal push gets rejected and the only way through is a force push, which is fine right up until a teammate has that branch checked out, so they pull. Git sees commits on the remote they do not have and commits locally that the remote does not have. And it does the helpful thing, it merges the two. Now the old commits and the new commits both exist. Every change appears twice and the history is genuinely broken. So this is the golden rule. Never rebase commits that other people have already based work on. And when you do force push your own branch, use force with lease rather than plain force. Force with lease refuses to override the remote if somebody else has pushed since you last fetched. It is the difference between rewriting your own work and deleting somebody else's. So put the whole thing together. The question was never really merge versus rebase. The question is, has anybody else seen these commits or not? If the answer is no, this branch is yours alone and you can rebase it as much as you like. Rebase onto main to pick up upstream changes, tidy the commits, keep the line straight. If the answer is yes, other people already have this history, then you merge because merging adds and rebasing replaces. You can always add to shared history, you can never safely replace it. Private history you rewrite, public history you only ever append to. That one sentence answers every rebase question you will ever have. Which brings us to the button you actually end up clicking. GitHub gives you three merge strategies and they're not cosmetic. Each one leaves main in a different state. Create a merge commit is a plain merge. All 8 commits land on main plus a merge commit joining them. You keep everything including the diamond and main gets a little bit busier every time somebody ships. Squash and merge takes all 8 of those commits and flattens them into a single commit on main. Main stays perfectly linear, one pull request equals one commit, and that makes bisect and revert almost embarrassingly simple. The cost is that your individual commits are gone from main forever. Whatever granularity you had is now one blob. Rebase and merge replace your 8 commits onto main individually with no merge commit at the end. So you keep all 8 commits and you keep the linear history as well, which sounds like it comfortably beats both of the others. But here's the trap. GitHub rebases them, which means GitHub rewrites them. The commits sitting on the main are not the commits sitting on your branch, and your local branch is instantly stale and diverged. Delete it and pull main rather than trying to carry on working in it. One more thing that catches people is that reverting a merge commit is not a normal revert. A merge commit has two parents, so a plain revert does not know what to undo. You'll have to tell it which parent is the main line using the dash m flag. Squashed and rebased histories never have that problem because there is no merge commit to revert in the first place. Last thing, and this is the one that actually lets you experiment without fear. Rebase feels dangerous because it destroys commits. Actually, it does not, at least not immediately. Those old commits are still sitting in the object database. They are simply unreferenced, and unreferenced is not the same thing as deleted. And git reflog shows you every position head has been in, including the one right before you started the rebase. Find that entry, hard reset to it, and your original branch is back exactly as it was. Those objects stay recoverable for around 90 days before garbage collection genuinely removes them. So a rebase you regret is not a rebase you have lost. Merge preserves the truth, rebase tells a cleaner version of it. Use rebase to clean up work that only you can see and merge to integrate work that everybody else can see. That is the entire decision. If this made rebase feel less like a landmine, a like genuinely helps. And subscribe if you want to see more of this. Thank you.